Today we shall be considering the topic capacitance of a capacitor. And at the end of these lectures, viewers will be able to define the term capacitor, list applications of capacitors, define capacitance of a capacitor, solve problems on capacitance of a capacitor, list factors affecting the capacitance of a capacitor, and finally solve mathematical problems on parallel plate capacitors. Let's get started. What is a capacitor? A capacitor is a device used to store electric charges. Capacitors are devices used in storing electric charges. They are used in tuning frequency of radio receivers. They can as well be used in eliminating sparking in automobile ignition system. Capacitor is a device used to store short-term energy for rapid release in electronic flash units. A capacitor is an isolated system of two conducting bodies of any shape and size separated by a distance. Any of those definitions are correct, so whichever you are convenient, you can apply them. It consists of two parallel plates separated by a distance d, used in an electric circuit. The plates are connected to the positive and the negative terminals of the battery or some other voltage sources. The insulating material placed between the plates of the capacitor is called dielectric substance. So a capacitor is a device that it consists of two metallic plates being separated by a distance, and in between them there is an insulating material that is placed in between them. That insulating material is called dielectric. So an insulating material placed in between the plates of the capacitor is simply referred to as dielectric substance. Capacitance increases with the area between the plates, and it decreases with increasing distance and increases with dielectric constant. I take it again. Capacitance increases with the area between the plates, decreases with increasing distance, and increases with dielectric constant. Look at this figure. This is a simple figure or diagram representing the parallel plate capacitor. On this diagram, you can see the positive terminal of the wire in red color and the negative terminal of the wire in black color. The positive terminal is connected to the positive side of the battery, and the negative terminal is connected to the negative side of the battery. The plates have area. The plates carry equal and opposite charges. Okay. Other applications of capacitors. Looking at this figure, I believe that you have, by one way or the other, come across any of these objects here. So these things you are seeing here, these are capacitors. These are capacitors. You may see them in your television set when it is opened, or your radio. most of the times in our electronic devices like the touch light. So they have a role to play even in our vehicles and computers and all of that. So other applications of the capacitor. The first one here is that they store energy. You can store energy. They are applied or used in coupling signals. They can as well be used in decoupling signals. They can be used in high pass and low pass filter, power factor correction, starting ignition of a vehicle, snubber circuit, DC power supplying filtering, and tuning radio. What is a capacitance of a capacitor? The capacitance of a capacitor is the ratio of the magnitude of the charge on either conductor to the magnitude of the potential difference between the conductors. I take it again. The capacitance of the capacitor is the ratio of the magnitude of the charge on either conductor to the magnitude of the potential difference between the conductors. The SI unit of capacitance is in farad. So if you don't use the term farad, which was named after the founder, you can as well use coulomb per volt. If the two conductors carrying opposite charge Q have potential difference V between them, then we use the expression Q equals to C change in V, equation 1. You can see this Q here represents the charge and C represents the capacitance of the capacitor and V represents the potential differences in potential. If we are solving for capacitance of a capacitor, then we'll make C the subject from equation 1. When we do that, we have Q over V, where C is the capacitance of the capacitor and its value depends on the size, the shape, distance of separation between the conductors, and the nature of the medium between them. One could ask, what are those factors that affect the capacitance of a capacitor? You can see them here: the size of the material, the shape, the distance of separation between the conductors, and the nature of the medium or the dielectric substance between them. If C subscript O, that's if C0 represents capacitance of a capacitor in a vacuum, and Cm is capacitance of a capacitor in a medium, then we can use this expression to find the dielectric constant of the material, K. Alright. I made mention that SI unit of capacitance of a capacitor is in farad. Here we have it that the farad is a large unit. So most of the times you may come across the micro-farad or the pico-farad. The micro is written, let me use my highlighter. You see this symbol here? this symbol for micro, and this P here is symbol for pico. This is micro, this is pico. So micro-farad, pico-farad. This micro means 10 to the power minus 6. Then pico means 10 to the power minus 12. So I've written it here. In case you see a write-up like this, maybe in a figure or in terms of different numbers, ten microfarad. In this case, it means the same thing as 10 times 10 to the power minus 6. So in place of microfarad, you replace 10 to the power minus 6. Here we have 20 picofarad. Picofarad means 10 to the power minus 12 farad. So in place of pico, you replace 10 to the power minus 12. Is that clear? Let's proceed. Example 1. This example says, if a 3.0 microfarad, and of course you know that this 3.0, this microfarad means this microfarad, this unit means 10 to the power minus 6, don't forget. If a 3.0 microfarad capacitor is connected to a 12-volt battery, just as you saw in the diagram in the figure, the magnitude of the charge on each plate of the capacitor is, indirectly the question wants us to find the magnitude of the charge, Q, on each plate of the capacitor. You, as a physicist, the first thing you have to do is you must highlight or put down the given quantities. When you do that, you now begin to think, which mathematical expression should I use? So that's the first thing we should do. Solution: we are given the value for the capacitance, which is 3 microfarad, is written here, and the potential difference, 12 volts. Looking at equation 1 or equation 2, you can see that we have two quantities, but one is missing. We have CV, and we are asked to find Q. So as it is now, it is convenient we use equation 1 because that question is simply a direct question. So we now pick our expression, Q equals CV. What could be the possible answer? I would like you to do the substitution because we have C here to be 3.0 times 10 to the power minus 6 farad, and V is 12. Just multiply both of them and check what your answer would be. Q equals to question sign. Okay, this is what I wanted you to do. (36 microcoulombs). Example 2. A capacitor of charge 4 picocoulomb has a potential of 100 volts. Estimate the capacitance of the capacitor. Look at the SI unit. 4 pico-coulomb and 100 volts. The unit I used to say is a language, tells you what the quantity is. So the first quantity is the charge. Second quantity is the potential difference. Compare the equation with the given quantities and solve for the unknown. If you are given Q and V, of course you know that Q equals to CV. You are to estimate the capacitance, meaning that you are just to make C the subject of that expression. That's the expression. Making C the subject, you have this. So if you don't understand how to make change of subject formula, go back to that mathematics, that topic, and practice it. Okay. Our Q is 4 times 10 to the power minus 12, and our V is 100. When we do the substitution here, it will give us the answer. You can as well change the denominator to standard form and then solve for, but if you compute it directly, you always arrive at the correct answer. But I decided to use standard form, so I had to change my denominator 100 volts to standard form as well. When you do that, from indices, you will get 4 times 10 to the power minus 12 minus 2, which will finally give you 4 times 10 to the power minus 14 farad. This answer is correct. But in a situation where maybe you have written an exam, the answer could be written either in pico-farad or in micro-farad. So in case you see something like this, it's not wrong. It's just that most of those values has been converted to the symbols here. So you have to be cautious when you are trying to answer problems on physics. So our final answer was 4 times 10 to the power minus 14 farad. So in a situation where you see 4 times 10 to the power minus 2 pico-farad, please do not be confused. Remember that pico here means 10 to the power minus 12. So if you have 10 to the power minus 12 times 10 to the power minus 2 still gives you 10 to the power 14. So it's still the same thing. Are you following? 10 to the power minus 12 and 10 to the power minus 2. So the minus 12 side of it has been converted to pico here. So we are now left with 10 to the power minus 2, which is still correct. Or you see something like 4 times 10 to the power minus 8 micro-farad. So here is 10 to the power minus 8, and of course this one is minus 6. So if you subtract this, of course it will still give you minus 14 as the index. So it's still correct. Look at it very well. Okay, I think I can proceed from here. Try this. A capacitor of charge 4 micro-coulomb has potential of 75 volts. Estimate the capacitance of the capacitor. This one is for you. I'll wait for you. Apply the expression. Pick a formula, substitute the value, and do your own calculation. Let me wait for you. Okay, so what is your answer? This is the expression to use. Compare your answer with what is here below, whether it's the same thing. Let's proceed. Parallel plate capacitors. If two parallel plate capacitors of charge Q, charge density, area of either plates, and area of the plates A, thus electric field strength is E between the plates. So you have that the electric field strength is equals to the ratio of charge density to the permittivity. We call it equation 4. That's an expression. You can as well use this depending on the equation given. Similarly, electric field strength is equal to Q over epsilon naught A, where symbol sigma represents the charge density, epsilon naught permittivity. Q is the charge, A is the area, E is electric field strength. Also recall that E equals to V over D. This is another expression. I'm using red pen so that you note them. Just keep memorizing. You see equation 1 or 4 here. You can as well memorize this. Also memorize this. So we have that electric field strength E equals to V over D, where V is the potential difference and D is the distance of separation between the plates. Putting equation 4a and 5. Where is equation 4a and where is equation 5? Look at equation 4a here. For electric field strength, E equals to Q over epsilon naught A. And equation 5 for electric field strength, E equals to V over D. So one can equate, we can just say V over D equals to Q over epsilon naught A. That's what we are about to do. So when you do that, you have V over D equals to Q over epsilon naught A. Hope you are with me. Okay. Now look at this equation. Here we have V. At this point we have Q. I'm going to cross multiply and bring Q down. When I bring Q down, I now take D to this other side. So when I do that, I will have V over Q equals to D over epsilon naught A. Cross multiplying, and then you obtain V over Q equals to D over epsilon naught A. Please pardon my numbering. This is supposed to be equation 6. The black one here, since I already have 4, 5. So let's ignore the numbering, but look at the expression V over Q equals to D over epsilon naught A. Now, if I turn this expression upside down, I rotate it the way it is, then I will have Q over V equals to epsilon naught A all over D. I just decide to turn it or invert it. I didn't do anything. Look at it. Now, remember that Q over V is capacitance. From our equation 1, Q over V is capacitance. So in place of Q over V, I decide to put capacitance. That gives us a new expression. All this I would expect you to memorize them because we are going to use or apply them. Where C is the capacitance in farad, A is the area of the plate in meters square. In case the area is given in centimeter, always know that it has to be converted to meters. So always look at the unit. If the unit is in centimeter in this case, then you have to convert it to meter square. Assuming it was in centimeter square, area centimeter square should be converted to meter square. So distance, D is the distance of separation, said that before, in meters. And of course, you also check if you are given an equation and the distance is in centimeter or even kilometer, or as the case may be, whatever unit, you have to convert it to meter. And the permittivity is given by the constant as written below. And the unit is in farad per meter. But charge equals to sigma A. Charge equals to the product of the charge density and the area. Example 3. Let's look at this example. This one says, a parallel plate capacitor has an area 2 times 10 to the power minus 4 meters square and a plate of separation 1.0 times 10 to the power minus 3 meter. Find the capacitance. How much charge is on the positive plate if the capacitor is connected to a 3-volt battery? Also calculate the charge density on the positive plate, assuming the density is uniform, and calculate the magnitude of the electric field between the plates. Okay, so we are to find A, B, C, and D. In the equation we were given initially, this other one, 2 times 10 to the power minus 4. 2 times 10 to the power minus 4. Of course, check the units. You see that this is an area, and this is D from the unit. We have to find the capacitance. In this case, you pick a suitable expression. Solution. So this is given. This one is also given. We pick a suitable expression C. equals epsilon naught A over D. So in place of A, we are going to put the value we have here. Then in place of D, we also substitute the value. Epsilon naught here, permittivity, is given. You put the value of the constant. When you do that, that's the constant. You obtain this, simplify this, and check your answer. Will be 1.77 times 10 to the power minus 12 farad. So the P here stands for pico-farad in place of the minus 12. In place of the minus 12, we had to put the pico. Do not forget that. The second one said, how much charge? So charge is Q. How much charge is on the positive plate if the capacitor is connected to a 3-volt battery? So to get the charge, we use this expression, substitute the given value for C and then the value for V. We converted the pico to 10 to the power minus 12. So we get Q equals to 5.31 times 10 to the power minus 12 C. The next one said the charge density on the positive plate, assuming the density is uniform. The charge density sigma, meaning that we are going to make this the subject is the charge density. Hope you're looking at it. We have Q from this example here. We already know what the area is, which was given at this point in the equation. Okay, so what we need to do is to make this the charge density the subject of that expression. Okay. Now substitute the given values. When you substitute the given values, you obtain this. Look at the SI unit. C over m squared. So that's the unit of the charge density. Then the last one said the magnitude of electric field between the plates. The magnitude of electric field. We listed some expressions for electric field. You now have to check the one that is given in the equation, what the quantities we have and which of this expression that would be suitable. So we have V and then we have distance of separation. So this one is complete. We now pick this, substitute the values for V and D, simplify it, and you get the final answer. Look at the unit. The unit for the electric field strength, volts per meter. The unit is very important, so you have to also memorize it as well. Look at this assignment. This one is for you. 2 plates, each of area 3 times 10 to the power minus 4 meters square, are used to construct a parallel plate conductor, parallel plate capacitor with capacitance 1 pico-farad. Find the necessary separation distance. Find the necessary separation distance. If the positive plate is to hold a charge of 5 times 10 to the power minus 12 coulomb, find the charge density. This one says, find the electric field between the plates. Find the electric field between the plates. And this one says, what voltage battery should be attached to the plates to obtain the preceding result? Alright, so when you do your calculation, you compare it with the given answers so that you know if you are correct. So I decided to put the answer below. When you calculate it, you compare. Alright. Thank you for watching. You are watching Supreme Online Lectures. We have our YouTube channel and our Facebook channel link. Please endeavor to subscribe to our channel, like it and share. Thank you for watching. Have a wonderful day.